Dear First Secondary, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Geometry Unit 3, Lesson 5. The lesson is called Applications of Similarity on the Circle. Inshallah, in this lesson, we are going to use the similarity to conclude some rules used in the circle. Let's start the lesson. The first rule with us called well-known problem. Let we have a circle like this and we have two triangles drawn inside the circle. Those two triangles formed from the intersection of the chord AC and another chord BD. E here is not the center of the circle. Let the center of the circle here in this position. Okay, now by looking to the two chords of the circle, formed angle A and the angle D, two inscribed angles, and they are equal in measure, and also angle B and the angle C, two inscribed angles subtended by the chord AD, and also they are equal in measure. By looking to the two triangles, we get two triangles similar because angle A equal to D and the angle B equal to C. I can say that triangle ABE is similar to triangle DCE. Again, ABE similar to DCE. And from the similarity, we get that AE over DE equal BE over CE, and also equal AB over DC, but I don't need this ratio. Okay, now I don't need the similarity anymore. Now by looking to these two chords, okay, we have this ratio by make a cross multiplication, AE times CE and BE times DE multiplication. The rule finally is CE times EA equal BE times DE. This is from the cross multiplication. Again, briefly, if we have two intersecting chords, so EA times EC equals EB times ED, and this is the rule. To make it easy to keep, start always from E, okay? So, or from the intersection point, EA times EC equal EB times ED. Another case, if we have a circle like this and also we have two intersecting line segment but comes from point outside the circle like this. Okay, now we have here ABDC is a cyclic quadrilateral because A, B, D and C lie on the circle. And we studied before that if we have an exterior angle for the quadrilateral, this exterior angle equals the opposite interior angle. So angle A equal to angle D. This is exterior and this is its opposite interior. And also angle B exterior for the quadrilateral. So it is equal to angle C like this. So we get that triangle EBA similar to triangle ECD. Again, EBA similar to triangle ECD, and from the similarity we get that AE over DE equals BE over CE. You can conclude, write the similarity, and you can conclude this one from the similarity. It's okay. By making the cross multiplication, AE times CE equals BE times DE like this. So EA times EC equal EB times ED. Again, start forever from the point of the intersection. EA times EC equals EB times ED. Again, EA, EC equal EB equal times ED. All started from E. Okay. Another rule, if we have also a circle and we have AB is a tangent to the circle, and we studied before that the tangent with the chord, with the nearest chord, form an angle called angle of tangency, which is angle ABC. Angle ABC equal to opposite inscribed angle D. So angle B equal to angle D. Now we have two triangles, triangle ABC and the triangle ADB. The two triangles are similar because angle B equal to angle D and the angle A is a common angle. Okay, now from the similarity, AB over AD equals AC over AB, like this, by making the cross multiplication. So AB times AB equal AB power of 2 equals AC times AD. Now I don't need this one anymore. Okay, so AB power of 2 equal AC times AD, and this is the rule we need. Okay, if we have a tangent, so AB to the power of 2 equals AC times AD. Now we get three rules: the intersection of inside the circle and the intersection out the circle and the tangent. Again, AB power of 2 equals AC times AD. Okay, using a calculator or mental math to find the numerical value of x in each of the following figures, length measure in centimeter. Okay, here two intersecting chords inside the circle. Okay, as we see before, EA times EB equals EC times ED. Now I'm going to write the rule: EA times EB, remember I started with E, equal EC times ED. Okay, EA equals 4, EBX equals EC 8 times ED 3 equals 24. By sending 4 to the other side as divided, so x equal 24 divided by 4 equal 6. Okay, the next one. Here we have ECED equal EA times EB. Again, ECED equal EA times EB. So 3x times 4x equals 6 times 18. Okay, and 6 times 18 equals 3 times 4 equal 100 equals 12x power of 2 equals 6 times 18 equals 108. By sending 12 as a divided, so x power of 2 equal 108 divided by 12 equals 9. By taking the square root, so x equal 3. But I don't write negative or positive 3 because x here is a length and the length is not negative, is always positive. Okay, the next question. Here I'm going to write the rule: E, starting from E, ED, EC equal EB, EA. Again, E, D, E, C, E, B, E, A. 6 and EC equal 6 plus x. Again, EC equal 6 plus x. So I'm going to write this one inside brackets, 6 plus x, like this, and EB equals 5 times EA equals 5 plus 12 plus 7 equals 12. The common mistake, some of us multiply 5 times 7. It's wrong. The right answer is 5 times 12. Okay, now I'm going to multiply 5 times 12 equal 60. I'm going to send 6 there as a divided, so 6 plus x equal 60 divided by 6 equal 10. And I'm going to send 6 minus, so x equal 10 minus 6 equals 4. Next. Okay, number 4. Now AD is a tangent, and remember with me the rule of the tangent. AD to the power of 2 equals AB AC. Repeat A. AD power of 2 means x power of 2 equals 7 times AC equals 7 plus 9 equals 16. So it will be 7 times 16. Okay, so x power of 2 equals 112 by taking the square root, so x equals square root 112, so x equals 4 square root 7. Okay, but I don't write negative or positive. I repeat this one. Now we have here AD also is a tangent, so AD square equals AB AC. Okay, now BX, BC and BA are equal, so AB also is called X. Now AD power of 2, 8 power of 2 equals AB equal X, and AC equal AC x plus x equal to x. So it will be like this: x times 2x equals 2x power of 2 equal 8 power of 2 equals 64. Send 2 divided, so x power of 2 equals 64 divided by 2 equals 32. Now take the square root for both sides, so x equal root 32 and x equal root 32 equals 4 square root 2. Now we have here intersection inside the circle and a tangent. So I will use two rules: the rule of the intersection inside the circle and the rule of the tangent. Okay, now it's better to use the numbers inside the circle because we have 10, 3.2 and 8. The missing is this one. I will call this one y, so LD y, so AC also equal y. Again, LD and AC equal. I'm going to call LD y, so AC also equal y. Now back to the circle. Inside the circle, LD LC equal LE LA LF. Again, LD LC equal LE LF. So 8y equals 3.2 times 10. So 8y equals 32. By sending 8 after 32 was divide, so y equal 32 divided by 8 equals 4. This is the value of y. So LD equal 4 and AC also equal 4. So this one equal 4. Okay, now I need to find the value of x. Here A, B power of 2 equals, I'm going to repeat A, so it is AC AD. AC times AD. So x power of 2 equals AC equals 4 times AD. Count with me AD, calculate AD. 4 plus 8 plus 4 equals 16. So this is 16 x power of 2 equals 4 times 16, 64 by taking the square root, so x equal 8. Now let's study the converse of the previous rules. We use the converse to prove that there is a circle passing through some points like this. If we have, as you see, two line segments, AC and BD. Okay, now this line segment may represent two chords inside the circle if what? If the product EA times EC equal the product EB times ED. Again, if EA times EC equal EB times ED, then there is a circle can passes through A, B, C, and D like this. CA times times EA times CE times EA equal BE times ED, as I said before. Then there is a circle that passes through A, B, C, and D, and the circle will be like this. We are going to use this rule when he asked me prove that there is a circle passes through the 4 points. Okay, another case. If we have 5 points like this, then A, B, D, and C may represented inside the circle when EA times EC equals EB times ED, like this. EA, EC equals BE times ED or DE. Okay, then there is a circle passes through A, B, D, and C like this, and in that case A, B, D, C is called cyclic quadrilateral, and also A, B, C, D is called cyclic quadrilateral. Don't forget, we use this rule when he asked me prove that there is a circle. The last case with us, if we have 4 points like this, and there's a triangle BCD like this, and he said prove that AB is a tangent to the circle. In that case, I have to prove that AB power of 2 equals AC times AD. Okay, again, AB power of 2 equals AC times AD. Then in that case, AB power of 2 equals AC times AD. In that case, there is a circle that passes through B, C, and D, and the circle will be like this. And in this case, BCD is called inscribed triangle. Again, AB power of 2 equals AC times AD. The next question, example 2. In which of the following figures, A, B, C, and D lie on a circle? Explain your answer. The lengths are measured by centimeters. Okay. Number 1. I need to know that there is a circle or not can passes through A, B, C, and D. Okay. Now I'm going to count EA times EB equals 5 times 20 equals 100, and EC times ED equals 10 times 10 equals also 100. Therefore, A, B, C, and D lie at one circle. Or by another meaning, A, C, B, D is a cyclic quadrilateral. Number 2. Now we have A, B, D, and C. I need to know that there is a circle passes through A, B, D, and C. So I will count EB times EA, which is equal EB3 times EA equals 3 plus 9, 12, equals 36, and ED times EC equals 4 times 9 equal 36. Therefore, A, B, C, and D lie at one circle. Okay. Now, in which of the following figures AB is a tangent to the circle which passes through the points B, C, and D? Okay, now to have a circle passes through forgive me for the bad drawing. Circle passes through B, C, and D. So to have AB to be a tangent, so I must count AB power of 2 and AB must equal AD times AC. Again, AB power of 2 equals what? Equals 4 power of 2 equals 16. And AD times AC equals 2 times AC equals 8, also equal 16. Therefore, AB is a tangent to the circle that pass through B, C, and D. Okay, now he asked me to prove that AB is a tangent to the circle passes through B, C, and D. Okay, now the shape of the circle will be like this. This is a very bad drawing, it's okay. Okay, now I need to find AB to prove evaluate AB power of 2. Okay, ABCD is a right angle triangle, so AB equals square root hypotenuse power of 2 minus side power of 2 square root 29 all power of 2 minus this side equal 5 centimeters. It will be 5 power of 2, so it is equal 2 centimeters. So AB equal 2. Okay, now AB power of 2 equals 2 power of 2 equal 4, and AC times AD equals 1 times AD equals 5. It is equal 5. So AB power of 2 doesn't equal AC times AD. Therefore, AB is not a tangent to the circle pass through B, C, and D. And D. Okay, the next question. In this question, XA is a tangent to the circle M at A. XA equal 15, XB equal 9. Calculate the radius length. Okay, in that case, it's better I'm going to call BM X, so CM also equal X. Okay, since XA is a tangent, therefore XA all power of 2 equal XB times XC. Okay, excuse me, I'm going to call this Y because there is X, another X, so this is Y, and also this is Y. Okay, xa power of 2, 15 power of 2 equals xb equals 9 times xc. xc here, bc equal to y, and this is 9, so it will be 2y plus 9. Okay, now I'm going to evaluate 15 power of 2, which is 225. So I'm going to send 9 by divided, so 2y plus 9 equals 225 divided by 9 equals 25. Again, 225 divided 9 equal 25. So I'm going to send 9 minus, so 2y equals 25 minus 9 equals 16. So I'm going to send 2 divided, therefore y equals 16 divided by 2 equals 8. Now, also we have AB is a tangent to the circle at B. C is a midpoint of A. D, AB equal 5 root 2. Find the length of AD. Also, I'm going to call this one X or Y. Okay, since AB is a tangent, therefore AB square equals AC times AD. So 5 square root 2 all power of 2 equals X times AD equals 2X. X times 2X equal 2X power of 2 equal 5 root 2 all power of 2 equal 50. I'm going to send 2 divided, so X power of 2 equal 50 divided by 2 equals 25. I'm going to take square root for both sides, so X equal root 25 equals 5. Now AC equal 5 and CD equal 5, so AD equal 10. Okay, now this is a very popular example. In the opposite figure, L belongs to XY, XL equal 4 and YL equal 8, M belongs to XZ, XM equals 6, ZM equals 2. First, prove that triangle XLM similar to triangle XZY. Okay, by looking to the two triangles, he asked me this triangle and the bigger triangle. We have here two sides and the included angle, and also in the big triangle, two sides and included angle. Okay, now I'm going to take XL over XZ. Since XL over XZ equals 4 over 8 equals half, and XM over XY equals 6 over 12 equals also half, and angle X is common, therefore triangle XLM similar to triangle XZY. Okay, this is the first required. The second required, prove that LYZM is a cyclic quadrilateral. I can prove this cyclic quadrilateral by two different ways. Okay, the first way, we proved that the two triangles are similar. So angle M equal to angle Y. Again, angle M equal to angle Y. Angle M is exterior for the quadrilateral and it's equal to the opposite interior, so this is a cyclic quadrilateral. Or angle L equal to angle Z. Angle L equal to angle Z. This is from the similarity. So also L is exterior and equal to Z, which is the opposite interior, so this is also a cyclic quadrilateral. This is the first way, but I will not use this way. Okay, I'm going to use the other way because this is related to our lesson. I need to prove LYZM is a cyclic quadrilateral. Okay, so I'm going to find XL times XY equals 4 times 12 equals 4 times 12 equals 48, and XM times XZ equals 6 times 8 equals 48. Therefore LMZY is a cyclic quadrilateral. Okay, now we have example 7. In this example, AB and CD intersect at E, where AE equal 12 and 12 BE, and DE equal 3 over 5 EC, B equal 6, C equal 5. Prove that the points A, B, C, and D lie on the same circle. First, I'm going to draw the two line segments AB and CD. This is A, B, C, and D. Okay, now AB, AE equal 5 over 12 BE, so AE equal 5 and BE equal 12, or by another way, AE over BE equal 5 over 12. Okay, and so since AE equal 5 over 12 BE, therefore AE equals 5x and BE equals 12x. Here BE equals 6. BE equals 6. This is BE. Therefore BE equals 6. Therefore 12x equal 6. By sin 12 after 6 was divided. Therefore x equal 6 divided 12 equals 0.5. Okay, now x equals 0.5. So AB, so AE, therefore AE equals 5 times 0.5 equals 2.5, and EB 12 times 0.5 equal 6. Now BE equal 6 and AE equals 2.5. Okay, the other part of the question, DE is 3x and EC is 5x. Since DE equal 3 over 5 EC, or DE over EC equals 3 over 5, both are correct. Therefore DE equal 3y, I will not use x in this time, and EC equal 5y. Okay, now we have CE equals 5. Therefore in place of EC I will write 5, so 5y equals 5. Therefore, y equal 5 divided by 5 equals 1. Okay, now DE equals 3 times 1 equals 3, and EC equals 5 times 1 equals 5. This is EC equals 5 and ED equals 3. Okay, now I need to prove A, B, C, and D lie in the same circle. Therefore, EA times EB equals 2.5 times 6 equal 2.5 times 6 equals 15, and ED times EC equals 3 times 5 equals 15. Therefore, A, C, B, and D lie on the same circle. And the circle will be like this. The next question. Okay, now we have two intersecting circles at A and B. So the first step, I'm going to draw two intersecting circles like this. I'm going to call this one A, this point A, and this point B, because they intersect at A and B. Okay, C belongs to the straight line AB, and C doesn't belong to AB. C is not here, C is outside AB. So first I'm going to draw to connect AB with a straight line. So for example, C will be here in this position. Okay, from C, the two tangents to CX and CY draw to touch the two circles at X and Y. From C, I'm going to draw tangent to this circle and tangent to the other circle. Okay, this is C. This one is called CX and this one is called CY. Now, prove that CX equal to CY. Okay, CX is a tangent. Since CX is a tangent, therefore CX power of 2 equal CA times CB. And since CY is a tangent, therefore CY power of 2 equals CA times CB. CY power of 2 equals CA times CB. This is number 1 and this is number 2. From 1 and 2, therefore CX power of 2 equals CY power of 2 by taking the square root without negative or positive. Therefore CX equal CY, and this is the required. Okay, the last example with us, example 9. Two concentric circles. Remember with me what the meaning of concentric. Concentric, two circles have the same center, common center, like this. This is the first circle and the second circle, and the common center called M. This is given. Okay, the length of their radii 12 and 7. The bigger one is 12 and the smaller one is 7. AD is a chord in the larger circle. So in the larger circle, I'm going to draw a line segment called AD like this. So this one is called A and this one is called D. Now, okay, to intersect the smaller circle at B and C, like this. Okay, the smaller circle B and C, okay, from prove that AB power of 2, AB times BD equals 95. Now, the previous rule depend on two chords. Now, I have just one chord. So I'm going to draw another chord, but it's better to use 12 and 7. So I need a diameter, not a chord, and passes through the point B like this. Again, I'm going to connect. This is construction. Draw the diameter to passes, okay, to use 12 and 7. Now, this distance, the bigger radius equal 12, and the small distance, this distance equals 7. Okay, again, this one equals 7, and this also 7, and from here to here equal 12, and from here to here equal 12 also. Okay, now since the radius of the larger circle equal 12, therefore D, or the diameter, equals 24. Okay, now this line segment, I'm going to call this one by any letter. For example, I'm going to call it E, and this one I'm going to call it F, for example. I'm going to call this one F. Okay, now to evaluate EB. Since EF is a diameter, in the larger circle, therefore EB equals 12 centimeters minus 7 centimeters equals 5 centimeters. So this one equal 5, which is EB. Okay, now since AD and EF are two chords in the larger circle, therefore AB times BD equals EB times BF. Okay, AB times BD equal EB equals 5 times BF. BF equal the diameter minus 5. Okay, 24 minus 5 equals 19. So it is equal 5 times 19 equals 95. And this is the required. And this is the end of the lesson. I hope it was helpful for you. See you inshallah in the next video. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.